Okay students, in this section we are going to discuss with the hydrogenation of the alkenes. Okay, let us understand what is hydrogenation. Hydrogenation is nothing but addition of hydrogen molecules to the carbon-carbon double bonds of a simple alkane compounds. Okay. So this reaction, it is possible to done with the hydrogen gas. Okay, so with the catalyst such as platinum, palladium or nickel. Okay, there are various reducing agents are available, but hydrogenation of alkenes, okay, generally it is possible done by the using of these metal catalyst which are under highly powdered. Okay, so finely powdered platinum, palladium or nickel. So what it gives? So it gives a large surface area for this reaction, and in this reaction we are also going to use the activated charcoal. Okay, so which gives a cavity for the reaction. Okay, so the general hydrogenation of reaction is represented by the carbon-carbon double bond. An alkene we have taken, hydrogen we are going to supply by the external connection by means of the cylinder, and we have to maintain the pressure for that one, and we are going to add the heterogeneous catalyst. So what is the meaning of heterogeneous catalyst? Heterogeneous catalyst means the one reagent and the another, they are not at all in the same phase, they are in the different phase. Okay, so let us take simple alkene. Okay, it is a gaseous molecule. Okay, hydrogen is also a gaseous molecule. And what about the catalyst? So it is in the solid phase. Means there are two different phases reactions are there. That is why heterogeneous catalyst. Okay, so if you take the higher alkenes, okay, so then the reagent alkene is liquid in state. Okay, so and the platinum, it is in solid in state. So that also constitutes the heterogeneous catalysis. That is the meaning of heterogeneous catalysis. Okay, so if you add this and this one in the presence of a platinum or palladium or nickel catalyst, so which gives rise to an simple alkane molecules, or we can say that one the hydrogens are added across the carbon-carbon double bond, and it is an exothermic reaction. See what about the delta H? Okay, enthalpy is minus 120 kilojoules per mole. So means that one, it is an exothermic reaction. The amount of energy is liberated to the surroundings. Okay, so how this reaction proceeds through? What is the mechanism for this one? Okay, so the mechanism is like this. So we are going to use the metals. Okay, so we know that one metals in the solid state, they have surfaces, that is called metal surface. Here metal surface is there. Okay, so and this metal surface, first the hydrogen gas and comes and it is going to absorbed on the metal surface. So what happens on the adsorption? First it is going to absorb. Okay, so then what happens? The dissociation of the hydrogen bond which is going to take place, or bond dissociation takes place, which leads to the two hydrogens, they adsorbed on the metal in the elemental state. Then what happens? The alkenes which comes in contact with this hydrogen, okay, or you can consider metal. Okay, when this alkene comes in contact with the metal surface, okay, so whatever the hydrogens that is available here, they are going to attach it to the carbon-carbon double bond. Okay, and so in this step, okay, the alkenes are converting into a alkanes. Okay, so then after the addition of these two hydrogens, okay, the metal is reproduced, means it is acting as a catalyst, means the metal is ready for the another hydrogenation, or we can say the metal is acting as a catalyst here. It is taking up the hydrogen and dissociation of hydrogen bond takes place, and this addition, these hydrogens get added to the alkenes, ultimately leads to the conversion of alkene to alkene. Okay, so this is the role of that is why the metal surface are acting as a catalyst here. Okay, so what are the advantages of this hydrogenation of alkenes? The advantages is, first one is the syn addition. Okay, so here if you observe the mechanism, in this step the two hydrogens are adding across the carbon-carbon double bond in a same phase, isn't it? In the same phase means the two hydrogens are adding in a thinner fashion or thin addition, isn't it? You get my point? Okay. So then another advantages of this reaction is, okay, so the metals and hydrogens, okay, they are only convert the carbon-carbon double bond to the single bond without affecting the other sensitive groups. Suppose example, if you take the alpha beta unsaturated cyclohexanone, okay, if you reduce it by means of the platinum in presence of hydrogen, okay, so only the carbon-carbon double bond is reduced. Okay, so then the carbonyl group, okay, you know, it is a sensitive group. Okay, it is not at all, it is unaffected. Okay, so the selectivity of these catalysts is, it is selectively reducing the carbon-carbon double bond. Okay, so this is called as hydrogenation of the alkenes. Okay, so when you are considering the role of catalyst, if you take the reaction coordinates in the x-axis and the enthalpy or energy of activation. Okay, so this is an hypothetical situation. Okay, so the difference between this one is energy of activation. Okay, if you are going to use the any metals, then the EA, energy of activation, gets reduced. Okay, so this is one of the property of a catalyst, isn't it? Okay, it reduces the energy of activation. Okay, so the reaction proceeds simply, okay, with the consumption of less amount of energy. Okay, so this is called as hydrogenation of alkenes.